Now dear student, we are going to discuss this question 2.28, and in this question it is given to you, show that the force on each plate of a parallel plate capacitor has a magnitude equal to 1 by 2 times of QE, clear, and Q is charge stored in a capacitor and E is the magnitude of electric field between the plates, clear to you. So now we are going to solve this question, so concentrate on a screen. Now dear student, let's suppose here we have a parallel plate capacitor. This is parallel plate capacitor. Let's suppose here we have positive charge and let's suppose this is negative charge, clear. Now let's suppose this parallel plate capacitor plate is having area, this is A, and inside this, or we can say between this space we have electric field, this is E, clear. So now we can calculate here total charge, this is present on a parallel plate capacitor in the form of surface charge density. So we can write like this, Q is given by sigma multiply A, clear to you. Now if we find value of electric field between these two parallel plates, we can say, let's suppose if we want to find electric field at this point, so we can say due to, let's suppose this is 1 and 2, due to 1 here we have electric field in this direction, that is E1, and this is E2, clear. So from here we can say, we can write like this, E net, this is given by E1 plus E2, clear. So E1 plus E2, now we know due to this, let's suppose this is infinite sheet, clear, and due to this infinite sheet we have value of E, this is sigma upon 2 epsilon naught, clear, and this is also sigma upon 2 epsilon naught. So from here we can say this is sigma upon epsilon naught, clear. So we can say value of E, this is given by sigma upon epsilon naught, clear everyone? Yes. Now what is our objective in this question? In this question is to calculate force acting on each plate, clear. Now let's suppose what I am doing here, listen carefully. Let's suppose spacing between these two parallel plates we have small d. Now let's suppose if I am displacing these, let's suppose I am increasing distance between these two parallel plates by delta x amount, clear. So now can we find that against this electric field we have to do some work? Yes. So we can write like this, work done, this should be equal to F dot delta x, clear. Now let's suppose I am exerting force in the right direction and displacement is also in the right direction. So directly I can say this is F multiply delta x, clear. Now important part, actually we have to do some work against electrostatic field, means definitely here electrostatic potential energy stored between parallel plate capacitor. So we can write like this, this is energy density and we can say multiplied with volume, clear. So volume, we can say volume, we can say the area of this plate and the displacement of the, we can say displacement of this parallel plate, clear. So from here you can say this one and this one cancel out, clear. So we can write like this, force, this is equal to U and this is multiply A, clear to you. Now from here we can write like this, this is 1 by 2 epsilon naught E square multiply A, clear. From here you can see we can write sigma, this should be equal to epsilon naught times of E, clear. So now we can say, let's suppose if I take epsilon naught and E in one bracket, then I can write like this, 1 by 2 epsilon naught E and E multiply A, clear. So we can say this value is what, sigma, clear, and sigma multiply A we have Q, clear. So we can say this is equal to 1 by 2 multiply, this is sigma, and I am writing like this, sigma A multiply E, clear. So sigma A it is given by Q, so we can say this is 1 by 2 times of QE, clear. So this is our proof, but actually we have to find what is exactly, what is the meaning of this half, clear, because we know that work done W, it should be equal to QV, or we can say what is meaning of this half of a factor, clear. Meaning of half factor is what, we know between these two parallel plates we have a uniform electric field, clear, but if we talk about outside the parallel plate capacitor we have value of electric field is 0. So this half is indicating that we are taking here value of force, that is average of the electric field, clear. I mean value of force, this is value of force, clear. So value of force is given by 1 by 2 times of QE. It means to the left side of this plate we have electric field E, here we have 0. So we are taking average value of electric field, this is E by 2, and we can say force is given by 1 by 2 times of QE. Clear everyone? So this is all about this question. Clear?